Hello, good morning to everybody. Hello,
Good morning, sir.
Morning, sir.
good morning. Okay, in the previous class, were discussing about the classifications of signals in both continuous and discrete, that is, even and odd signals. Given the definition of even and odd signals and its mathematical expressions and decomposition of a signal into even and odd components. One example also was solved. Next, so the next class of signal is periodic and non-periodic signals. Periodic and non-periodic signals. What do we mean by periodicity? Periodicity means if any signal repeats the same pattern, we'll call such signal as a periodic signals. For example, when you take a sinusoidal signal, what is there in the range of 0 to 2 pi? 0 to pi you will find the positive cycle and pi to 2 pi you will find the negative cycle. Same pattern repeats 2 pi to 4 pi, 4 pi to 6 pi like that. Such signals we call as periodic signals. Any signal is said to be periodic if the same pattern of signal repeats what is there in that short duration. Please mute your microphone. Now, mathematically, we can write that any continuous time signal x of t is said to be periodic if it satisfies the condition called, that is, x of t equals to x of t plus capital T. Any continuous time signal is said to be periodic if it satisfies the condition called x of t is equal to x of t plus capital T. What is capital T here? Where capital T is the fundamental period. Where capital T is the fundamental period. What is that fundamental period? Fundamental period means it is the smallest duration. After that, signal repeats. We'll call such pattern as a periodic signal. Okay. Capital T is the fundamental period. It is the smallest duration. After that small duration, the same pattern of signal repeats. Example for a periodic signal here is, suppose if we take a signal this is for T, this is 1, this is 0, this is x of T, 1, 2, 3, 4, 5, 6, 7, 8, we'll call this signal as a periodic signal. What is the pattern repeat series? 0 to 2 signal is in a triangular shape. That is 0 to 1 it is linearly increases. 1 to 2 is linearly decreases. Same pattern is there from 2 to 4. Okay, again same pattern is there from 4 to 6. That means what is the fundamental period here? Fundamental period is, in this case, signal what is there in this range 0 to 2, same pattern of the signal repeats. Same pattern of the signal repeats. We'll call that period as a fundamental period. And here, in this case, we take t is equal to 2 seconds. Take t is equal to 2 seconds. Now you can check with this mathematical equation, that is x of t is equal to, you have x fundamental period is 2, that is t plus 2. X of t is equal to x of t plus 2. Now, suppose we can take any number as when t is 1, will become as x of 1 is equal to x of 3. See, x of 1 value is 1, x of 3 value is also 1. Suppose if I take when t is 2, x of 2 must be same as x of 4. As x of 2 value is 0, x of 4 value is also 0. Okay. That means it is satisfying the mathematical expression what I have given for the periodicity. That is x of t is equal to x of t plus capital T. Similarly, in case of discrete, you can say that any signal is said to be periodic if it is satisfied the condition called x of n is equal to x of n plus capital N. X of n plus capital N, where capital N is the fundamental. And similarly, we can do the definition for non-periodicity here itself. Any signal is said to be non-periodic if it does not satisfy this condition. X of t, if it is not equal to x of t plus capital T, then we'll call such signals as a non-periodic signal. Once again, I'll repeat the periodic signal. Any continuous time signal x of t is said to be periodic if it satisfies the condition called x of t is equal to x of t plus capital T. This is an example for the periodic signal, where capital T is the fundamental period. If signal does not satisfy this condition, x of t is equal to x of t plus capital T. If this condition does not satisfy, then we'll call such signal as a non-periodic signal. That is, for example, for non-periodic signal is, suppose if the signal is there like this, okay? 0 to 1, 2, that is, this value is 1. This is the x of t, and this is the t. Okay. So here there is no any repetition of any pattern here. Here there is no any repetition of any pattern. We'll call such signals as a non-periodic signal. Here there is no fundamental period because what is there in 0 to 2 range that is not repeated. Okay. We call such signals as a non-periodic signals. Okay. Next, similarly, in case of discrete power, any discrete time signal is said to be periodic if it satisfies the condition called x of n is equal to x of n plus capital N. That is where n is the fundamental period, where n is the again important as a fundamental period. Okay. Example for this discrete time periodic signal is, shall I erase the board? Shall I erase the board?
Yes, sir. Yes, sir.
X of n is equal to x of n plus capital, where n is the fundamental, where n is the fundamental period. Now, example for this is one, 2, 3, 4, 0, 1, 9, 1, 2, 2, 3. Next we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is n. 1, 2, 3. See, we'll call this as a periodic signal because see how the pattern repeats here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. No. 4 samples. What you have here is that is repeating. That is x of n is the x of What is the fundamental period in this case? What is the fundamental period? Hello? Hello? What is the fundamental period? Hello? Hello? Lavanya? Lavanya? Kalpana?
Yes.
What is the fundamental period in this case? What is the fundamental period? What is the n value, capital N value? How many samples are repeating here? How many samples are repeating?
4.
Huh?
Sir.
How many samples are repeating? What pattern is repeating here?
4, sir. 1 to 4.
4. Here, that is number of samples are that 1, 2, 3, 4. These 4 samples are repeating here. That's why we take the fundamental period as 4. We take the fundamental period as 4. Now, if you want, you can start with a mathematical expression, that is x of n is equal to x of n plus 4. And n is 1. What do you have? That is x of 1 is equal to 1 plus 4 is, that is 5. X of 1 is equal to, that means x of 1 value is 2, x of 5 value is also 2. You can take x of 3, x of 3 is equal to x of 7, x of 3 value is 4, x of 7 value is also 4. That means you can say that this is a periodic signal. It is satisfying the condition for x of n is equal to x of n plus fundamental period, that is capital N. Okay. Is it clear? Is it clear? Hello?
Yes, sir. Yes.
Now,
Yes,
when
sir.
this condition does not satisfy us, we will call such signals as non-periodic signals. Any signal is said to be non-periodic if it does not satisfy the condition x of n is equal to x of n plus capital N. That is example for non-periodic is signals is, suppose we have a signal that is 1, 2, 3, 0, 1, 2. This is n. This is x of n. That means what you have here? You have samples 1, 2, 3. See, only 3 samples are there in this signal. There is no repetition of any samples or any pattern here. That's why we'll call such signals as a non-periodic signals. Okay, definitions of periodic and non-periodic are very, very important here. Okay. In case of continuous, any continuous time signal is said to be periodic if it satisfies the condition called x of t is equal to x of t plus capital T. If this condition does not satisfy, call it as a non-periodic. Similarly, in case of discrete, any discrete time signal is said to be periodic if it satisfies the condition called x of n is equal to x of n plus capital N. If this condition does not satisfy, we'll call such signals as a non-periodic signals. Okay. Over. Shall I erase the board? Hello?
Yes, sir. Yes.
Yes, sir.
Now, next job is how to find the periodicity of a signal and say it is a periodic. Okay? To find the periodicity of a signal, to find periodicity of a signal, if it is single signal, Suppose you have an x of t is equal to cos of 5 pi t. Assume that this is one signal. This is a cos signal, cos or sine or anything. Cos of 5 pi t. One example. Second one is x of t is equal to sine of root 2 pi into t. Root 2 pi into t. Okay. When you have this type of signals, when signals are not represented graphically, then there's another method of finding out whether it's periodic or non-periodic. If you say it's a periodic, you should find out its fundamental period. If you say it is a non-periodic, then you don't need to find out its fundamental period. Okay. Now, here for signal, they give that x of t is equal to cos of pi t. That is, first step I should say that this is periodic or non-periodic, which is in the form of x of t is equal to cos of omega t, because we know that how cos and sine signals are cos of omega t, where omega is the 2 pi f. Okay. When you compare this with the cos of pi t, omega will become that is pi pi. Omega is the pi pi. What is omega here? That is 2 pi f is equal to pi pi. Then it is 2 pi by f is nothing but 1 by t. Frequency is equal to 1 by something, and that is 2 pi by t, that is equal to 5 pi. T is equal to pi pi get cancels. Here it will become that is 2 by pi. If this fundamental period 2 by pi what we got, if it is a rational number, if it is a rational, you know what is a rational number? What is a rational number? Can anybody give the answer? What is the definition of rational number?
Forms.
Hello?
Which
Hello?
is in P by Q forms.
Is in the form of
P by Q.
P by Q, where Q is not equal to 0, when both P and Q must be integers. Is it right? Hello?
Yes, sir.
Now, if that fundamental period what you find from the given signal, which is expressed in terms of trigonometric functions, if that fundamental period is a rational number, then we can say that signal is periodic. Okay. Now, 2 by 5 is it a rational number or not? 2 by 5 is it rational or irrational number?
Rational, sir.
It's a rational number. Hence, the signal is said to be periodic. Since the fundamental period is a rational number, since t is a rational number, since t is a rational number, t is a rational number, that is x of t is said to be periodic. Is said to be periodic. We can take a second case. In the second example, what is omega here? Omega is equal to root 2 pi. Omega is equal to root 2 pi. That is omega is 2 pi f is equal to root 2 into pi. That is 2 pi by t is equal to root 2 into pi, where t is equal to, this is get cancelled. That is 2 by root 2. Answer will become root 2 by 1. Root 2 by 1. What is the fundamental period you have got here? What is the fundamental period you have got? Hello? What is the fundamental period you have got? Hello? Hello? What is the fundamental period you have here? T, capital T.
Root 2.
Root 2, is it rational or irrational number?
Irrational.
Is it rational number or irrational number? Root 2 by 1, is it rational number or irrational number? Hello? Lavanya.
Sir,
Root 2, is it rational number or irrational number?
irrational.
It is irrational number. hence the signal is said to be non-periodic. Since the t is an irrational number, okay, since here you write, since capital T is the irrational number, is an irrational number. Since capital T is an irrational number, that is x of t is said to be non-periodic, is non-periodic signal, is non-periodic signal. Understood? How to find a periodicity of a signal and how to check its periodicity and how to get its fundamental period. Is it clear? Hello?
Yes, sir.
Yes.
Now, here you have individual signals you are able to find. So in some cases, signal is a combination of more than one signal. Suppose that is x of t is equal to cos of pi t plus sin of 3 pi t plus cos of 6 pi. Okay. Before that, there is one example is cos of suppose it has something like this. Example, so say x1 of t, x2 of t plus x3 of t. Assume that I have three signals. x1 of t plus x2 of t. Next, I'll do the example. x1 of t plus x2 of t, x of t, x3 of t. X of t is a combination of three signals, x1, x2, and x3. In such case, I should check that the given x of t is periodic or non-periodic. If it is periodic, we should find its fundamental period. In such case, what we should do is, the procedure is there, that is to find its periodicity. Step number 1, find the fundamental period of individual signals. Find the fundamental period of individual signals. Suppose you have x1 of t, I'll take its fundamental period as t1. Next, you have another signal x2 of t, its fundamental period is t2. Next, you have another signal x3 of t, its fundamental period is t. Assume that we calculated that. Okay, what I did is I have taken the individual signals, I have found its fundamental period. Fundamental period of x1 of t is t1. Fundamental period of x2 of t is t2. Fundamental period of x3 of t is t3. This is step number 1. Next, step number 2. What we should do is find the ratios. That is, find the ratios T1 by T2 and T1 by T3. T1 as a constant in the numerator, in the every ratio. Okay, that is T1 by T2 first ratio, T1 by T3 is second ratio. Suppose we have a fourth signal, T1 by T4 you need to calculate. If these ratios, T1 by T2 and T1 by T3, if these ratios are rational numbers, then the given signal x of t is set to be periodic. If the ratios are rational numbers, if ratios are rational numbers, then x of t is said to be periodic. If any one of them is irrational number, then signal is said to be non-periodic. then signal is said to be non-periodic. Okay. Next, once you say that it is in periodic, if it is a periodic, next step number 3 is you should find out its fundamental period. That is, step number 3 is finding out the fundamental period. In step number 3, to find the fundamental period of x of t, first step what we should do is find the LCM of denominators of the ratio. Find the LCM of denominators of the ratios. Ratios are T2 and T3. Okay, that is the ratios are T1 by T2 and T1 by T3. Denominators are T2 and T3. Find out the LCM. Let us take this LCM as L. Let us take this LCM value is L. Then the fundamental period is capital T is equal to T1 into L. This is the fundamental period of one signal. Okay, once again, I'll repeat the steps here. Once again, I'll repeat the steps. If the signal is a composition of more than one signal, if signal is a composition of more than one signal, then what we should do? Step number 1, calculate the fundamental periods of individual signals. Calculate the fundamental period of individual signals, T1, T2, and T3. Okay, if signal is composition of 3 signals, x1, x2, x3, find the fundamental period of x1 of t, find the fundamental period of x2 of t, find the fundamental period of x3 of t. That is T1, T2, T3 we need to calculate. That is step number 1. In step number 2, what we should do? Find the ratios. Ratios are T1 by T2. Keep the T1 as constant in the numerator. T1 by T2, T1 by T3. Okay. If these ratios are rational numbers, and the given signal is said to be, periodic. If one of these ratios is irrational number, then the given signal is said to be non-periodic. If you say it is a non-periodic, then you don't need to go for step number 3 because you cannot find the fundamental period. Suppose if you say that it is a periodic, then we should find out its fundamental period. To find the fundamental period, what we should do is first in step number 3, get the LCM of T2 and T3. Get the LCM of T2 and T3, that is denominators of the ratios, T2 and T3. Let us take that value as L. Fundamental period is given by T1, fundamental period of the first signal, T1 into L. That gives the fundamental period of the x of t. Is it clear? Hello?
Yes, sir.
Yes, yes.
Yes, sir.
Okay. Shall I erase the board now?
Yes, sir.
Yes.
Now, example here is, I take x of t is equal to cos of 7 pi t plus sin of 3 pi t plus cos square of 4 pi t. Okay? Or you can take as cos. After that, we will cos square factors. Now, how many signals are there? We have 3 signals here. That is, I'll take this as an x1 of t. I'll take this as an x2 of t. I'll take this one as an x3 of t. Okay. Now, what is x1 of t here? x1 of step number 1. x1 of t is equal to, you have cos of 7 pi t. Okay. What is its fundamental period? That is, you can keep it omega 1 is equal to 7 pi. That is 2 pi f1 is equal to 7 pi. Then 2 pi by t1 is equal to 7 pi. That is t1 is equal to, you have, that is 2 by 7. t1 is equal to 2 by 7. Similarly, you have that is x2 of t is equal to sine of 3 pi t, that is omega 2 is equal to 3 pi, that is 2 pi, f2 is equal to 3 pi, that is 2 pi by t2 is equal to 3 pi, then you have t2 is equal to 2 by 3. Similarly, from x3 of t is equal to, we have cos of 4 pi t. Here, omega 3 is equal to 4 pi, that is 2 pi f3 is equal to 4 pi, that is 2 pi by t3 is equal to 4 pi. Then t3 is pi get cancelled. 2 under 2, the answer is 1 by 2. Got t1, t2, and t3. Then you go for the step number 2. Find the ratios. Ratios are, that is t1 by t2. What is t1? That is you have 2 by 7. t2 value is you have 2 by 3. Answer is what our answer will get? It will become 3 by 7. 2 to get cancels. Next ratio here it is, that is t1 by t3. t1 is 2 by 7. t3 is, that is 1 by 2. The answer is you have 4 by 7. Is it right? Ratios calculations. Is it right?
Yes, sir.
Yes, sir.
Now, signal is periodic or non-periodic now?
Periodic.
Periodic or non-periodic?
Periodic.
Periodic.
Why it is periodic? Because both the ratios are
Rational number.
Rational.
rational numbers. Okay. Since ratios are rational numbers, the signal x of t is periodic. The signal x of t is periodic. If it is a periodic, then you should find out its fundamental period. Okay. Now, step number 3. To find the fundamental period, what I should take? I should take the LCM of the denominators of the ratio. That is LCM of T2, T3. That is LCM of T2 value is denominators of the ratios. T1 by T2 is 3 by 7. 7 is denominator. Here T1 by T3 is 4 by 7. Denominators. What is LCM of 7 and 7? 7 comma 7 is 7 itself. Is it right? Hello?
Yes,
Hello?
sir.
Okay. Now, once you have the LCM, then its fundamental period is given by T1 into, that is, you can take this as L into L, that is T1 is equal to, T1 value is how much? That is 2 by 7, into L value is 7 get cancels, fundamental period is 2 seconds. That is T is equal to 2. This completes the problem. Okay?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
Okay. This
Yes.
completes the second class of signals, that is periodic and non-periodic. I given the definitions for both discrete and continuous, periodic and non-periodic signals, and I taught the how to find the fundamental period of individual signals and how to find the fundamental period of composition of signals. Okay. With this, I'll stop the class now. Okay, thank you. Shall I leave the class now?
Thank you, sir.
Yes, sir.